This is the Magnetic Fields Homework Booklet, question 18. State Lenz's law. So you should know that the direction of the induced EMF is such as to oppose the change that produces it. So whereas Faraday's law gives you the magnitude of an induced EMF, Lenz's law tells you about the direction. This is a consequence of the principle of conservation of energy, because when electricity is generated, that's a form of energy, work must be done to achieve that. And that is why there is a force that opposes the change. Next, you're asked to consider two small solid cylinders, P and Q, made of aluminium and steel. They have identical dimensions, but Q has a greater mass than P. You are asked to explain what material property is responsible for this difference. So the key difference is the density. And since mass is density times volume, and the volumes are identical, the difference in mass must be due to a difference in density. Now, because this question says explain, I think you should go as far as making it clear that the density of the steel is greater than the density of the aluminium. Next, you are told that the cylinders are released from rest and allowed to fall freely through a vertical distance of 1 metre, and that this takes 0.45 seconds to occur. You're asked to justify the value and explain why the times are the same. So if we consider equations of motion and what would be causing the fall and the acceleration, clearly it is due to the force of gravity. Now in both cases, the acceleration is the acceleration due to gravity. And this value, which we know to be 9.81, is independent of mass. And that is one of the 2 points. That's explaining why the value ends up the same. You can consider the weight, mg, as equal to the resultant force, ma, which reveals that the acceleration due to gravity is independent of mass. Having done that, you can justify the value. So filling in that the distance fallen is 1 metre and that the acceleration is 9.81 and the initial velocity is 0, we have s equals a half gt squared. Substitution of your values and some careful rearranging leads you to the answer of 0.45 seconds. Next, you are told that the steel cylinder Q is a strong permanent magnet. P and Q are released separately from the top of a long vertical copper tube, so they pass down the centre of the tube, as shown in this diagram. So just remember, Q is the magnet, whereas P is not. The time taken for Q to pass through the tube is much longer than the time taken by P. You are asked to explain, first of all, why you would expect an EMF to be induced in the tube as Q passes through it. Now, since Q is a magnet, you must imagine around Q that there is a magnetic field. So as the magnet passes through the tube, there is a change of flux linkage across the cross-sectional area of the tube. You could also consider that lines of flux are being cut by the tube. Now, Faraday's law says that the size of an induced EMF is equal to the rate of change of flux linkage. So whenever there is a change of flux linkage, an EMF will be induced. And that is the key point that you need to make here. Next, you're asked to state the consequence of this induced EMF and then explain why Q takes longer to pass through than P. Now, both the tubes are mentioned here, so I think you need to at least make 1 point referring to P. There are 3 marks allocated here, and you would need 3 of these bullet points. So, the induced EMF, when Q falls, produces a current in the copper tube. Now, the consequence of the current will be that there will be a magnetic field around the tube. Now, this magnetic field, because of Lenz's law, must oppose the field of Q, and therefore it produces an upward force which acts against the motion of Q. Comparing that to P, since P is not a magnet, no EMF is induced, and it follows that there will be no current and no opposing magnetic field. Next, you are told that the copper tube is replaced by a tube of the same dimensions but made from brass. The resistivity of brass is much greater than that of copper. You are asked to describe and explain how, if at all, the times taken by P and Q to pass through would be affected. So first of all, considering P, there will be no change whatsoever. Since P is not a magnet, there is still no induced EMF, and so there will be no repulsive force affecting the motion. However, for Q, there will be some changes. So the resistance of the brass is going to be proportional to resistivity. So if the resistivity is greater, so is the resistance. A greater resistance will lead to a smaller current being induced, and the smaller current induced will lead to a weaker induced magnetic field. That means that the upward force that's opposing the motion will also be less. The consequence of that is that the time for Q to fall is shorter than it previously was, so it's not going to be delayed to the same extent as previously.